Hello everyone. Hello. Good evening. Good evening, Prashant. We'll start in 2 minutes. Let everyone join in. Hello Devika. Hello Afsal. Good evening, Gayatri. Hello everyone. Yes, we'll start in a minute. Let everyone join in. Till then, if anyone have any doubt in the problems we discussed yesterday, you may mention them here. We discussed one problem which was best maximum profit in buying or selling a stock, and um the second problem we discussed was number of arrays with subarray sum, number of subarrays with sum equal to k. Yes. So if you guys have any doubt, then we can discuss them here. So today we will be talking about a very important algorithm, a very important algorithm actually, which will be Cadane's algorithm. So we'll be talking about this problem. Find the subarray with the largest sum and return its sum. Try to read about this problem. Try to mark your observations, just like we talked about. Try to think about what kind of observations are you getting from this problem. Yes, Prashant, exactly. Adityan says the last problem was not clear, so will you explain? Okay. So till then, everyone try to think about this problem. Till then, everyone try to do that. Uh, Okay, so the last problem that we talked about, it was something like this. Subarray sum equal to k. We were saying that sum of this segment is equal to cumulative sum of this segment minus sum till this segment, right? This is sum of this segment. This is the first. This is the first observation that we have, right? How can you calculate any segment? You should have the endpoint sum till the endpoint and sum till the one position minus the endpoint. That gives you the sum between the values, right? So this is okay. So using this approach, using this observation, we already devised uh, one method which was trying for all pairs. Okay, but we also realized that this is O of n square, which is not valid. So we went on to see that we only care about if prefix of I minus k occurs or not, right? Let's say you are standing here, right? You have to see, what you have to see is, you have to see how many subarrays can be formed with this endpoint. You are fixing the endpoint. Now, what do you want? You want, let's say the sum was x. You want x minus k sum from here such that this x minus k minus x becomes equal to k, right? So you're just trying to see the frequency of the arrays which you have frequency of the sums which are stored in the mapping known as MP. This is a unordered map in C++ or hash map. What this gives you is, it gives you this answer is in O of 1, right? So that's what we were doing. Now this problem, we are looking at maximum subarray problem. Try to think about this problem. Okay, so I hope that everyone has read the problem. So let's try and see what are we trying to. Okay, so some of the things are very simple. We are being asked a subarray sum. Okay, maybe we can use something like prefix here or something. No. So now don't be very worried if you didn't get any idea. This is a new algorithm known as Cadane's algorithm. Good evening, Yuvraj. Good evening. And what this algorithm says, it says that initialize sum equal to 0. Sum denotes the cumulative sum, and global, we don't need actually global keyword here, right? We just need a keyword which should be named as maximum. Maximum equal to 0. Now what do we want? We want something like this. For int I equal to 0 to n minus 1. Okay, so the question being asked is here maximum subarray. Okay, Devika. So they are asking there will be an array. There will be an array something like this 3 2 1 minus 1 0 4 2. You want to tell me the maximum subarray. In this case, the maximum subarray is the whole array itself, but you can take a better example like 3 minus 4 1 10 minus 100. So in this case, this will be the maximum sum subarray with the sum equal to 11. Oops. Right, you can take this example minus 3 minus 4 1 10 minus 100, and here the answer will be 11. Okay. Now don't stress over if you don't get any approach, how to approach this problem, because this is a new algorithm altogether. This is known as cadence algorithm. Now what we do is sum plus equal to right, sum equal to sum plus a of I maximum equal to max of maximum comma sum if less than 0 and equal to 0. Now what's the point behind this algorithm, right? What is the point behind it? I hope the screen is showing now. What is the point behind this algorithm? Let's see. Let's take the example we took above. If at any point, if at any point your cumulative sum becomes less than equal to 0, you don't really need that portion, right? Think about it. Do you need that portion? You don't. You really don't. So whenever it becomes less than equal to 0, you simply initialize sum to be equal to 0 because you don't really need this portion. Why? Why you are able to do it? Because you know an empty subarray gives you an answer to be 0. Why do you need all of that array? Because an empty subarray already gives you an answer to be 0. So your answer is already, there is a ceiling on your, you can't go below this ceiling. Why? Because you always have the option of taking empty array, empty subarray, right? I hope it's clear to all. Is it clear to all? Why we are capping our answer? Why we are putting a limit on our answer? Lower limit. We know the answer can never be less than. Just give me a second. Okay, so my bad, my bad. Um, okay, my bad. So answer can be less than 0 because they are saying non-empty. The subarray should be non-empty. That's what they are saying. Okay, so if the subarray is non-empty, then answer can be less than 0. But still, let's try to see if let's try to see the case when um, let's try to see the case when the all the elements of the array will not be negative. All the elements are not negative. There is at least one element positive. So you know You always have a better option than 0. That's why you cap your answer on 0. You just take away this portion whenever it is hitting 0, and you take, whenever it is less than equal to 0, you do sum equal to 0. Okay, I hope it is clear to all. Now let's try and code this solution. Coding this solution should indeed be easy. In sum equal to 0 max, let's just do max equal to 0, or int I equal to 0. Okay, it should work most probably. Yes, it works. Uh, See, it works and a solution beats 100% of the users. Right. So just tell me if anyone have any doubt in what we have discussed in this problem. Okay, okay, I will explain my code. I will do that. Uh, Arif Ali is asking, is it compulsory to use vector only, not array? Um, See, Arif, uh, honestly, they both work fine. They both have the same utility. I am using vector. It's not my choice. It's because lead code is using vectors. That's why I'm using vector. Otherwise, there is no compulsion to use. You can even use arrays. But see, yes, yes, I will explain. So the point is, look at this. We said this is the running sum and this is the global maximum. So we are doing initializing global maximum and cumulative sum. In this case, it is sum and it is max. Now what we are doing, We are just implying the same algorithm that we discussed. Ayush says why max is not initialized to be 0. Okay, so this is a very important point pointed out by Ayush. I have initialized with int minimum. Why I have done that? Just give me a second. Just give me a second and see. There can be a case like this: -5, -6, -3, -2. Answer for this would be -2. For such cases would be -2, right? And here are Caden's algorithm. We cannot always cap our answer to 0, right? But we know that if all the elements are negative, then the answer is the maximum element. This is the maximum subarray, because if any part you take in that subarray, that will decrease the sum because all the elements are negative, right? I think Ayush had this doubt. So that's why I initialized my answer, my maximum, with int min. So you can initialize this with int minimum. Okay, and this generally ranges to be -2 raised to power 31. Okay, I hope this is clear and it works. Okay, so does anyone have any doubt? They can ask me, or we can also continue with the problems. Uh, Casey Reddy says how to get the array itself, not the value. I didn't understand your doubt. Can you please elaborate? Okay, Gaurav. Okay. SS Gaming did not understand. Okay. So SS, try to code it down by yourself. I feel like that will be a good practice. Try to code this. Don't see my code. Try to code it down yourself. Devika says, what is -2 Actually, it is the like it is the minimum value an integer can attain. So you know that there will this I can write it down here, that in minimum equal to 2 raised to the power -51. Sort of that only. Minimum value of integer in C++. Say it's -2 raised to power 31. Okay. No, Casey Reddy, it was asked, the sum was asked in this problem. If you, so you are saying to me, can I also answer in this problem only the sum was asked? Okay, so your concern is, can we get, okay, so try to do this problem. Try to merge these two problems. If you also want to get index, right? This is a nice problem. Try to merge these problems together. These, this one and this one. Try to merge them. You found sum equal to maximum sum. Let it be k. Put this k here and apply this algorithm. This also takes O of n. This also takes O of n. Right? What you were doing? You were finding a sum and you are finding a position. If you found a position, then you can say this is I and this is j, and I comma j is a subarray with sum equal to k, and k will be your maximum sum, right? Yes, Sana, you are right, but I'm trying to teach it in C++ because C++ has some benefits when it comes to competitive ground, competitive coding contests. C++ codes generally run faster. So I think we should just first give you the attendance link. Okay, so it's time that we should be studying about binary search. Why binary search? Sometimes it makes our life pretty simple. So let me try to introduce you to one such problem. It is this. You have to search an element in the array which is already sorted in ascending order. You have to search if this target exists. If it does, then return the index. Otherwise, return -1. Try to think about how can you exploit the condition of that this array is sorted. Okay, so let's do another problem which is simply binary search. Okay, so when is binary search actually used? Okay, so binary search means whenever you try to reduce your search space, let's say you have two pointers here, you try to reduce your search space from this search space to this, then to this, then to this, like see something like this. Try to reduce your search space to this. Okay, now you reduced it to half. Okay, now again reduced it to half. Okay, now again reduced to half. Okay, now can you see that you are reducing the search space to half? This is what binary search does. Rather than doing linearly searching for all the elements, you kind of fluctuate between different possibilities. Mostly you try to cut your search space, dissect your search space into half, basically bisecting the search space, right? This is a very simple problem of binary search, which is to search the element. You are given a sorted array and you have to search for, let's say, 6. You have two pointers, one here and here, and you have to search for 6, right? And this is 0, 1, 2, 3, 4, 5, 6, 7. Let's say you have a pointer here at an empty cell 8. We know we'll never reach this 8, right? Because what we will be doing was L, this is R, L plus R divided by 2. And we know this will always be less than equal to R, less than equal to L. Why? Because we know that it takes floor, right? It takes the floor value of the of this division. So we know that 0 plus 8 divided by 2 will be equal to 4. 3 plus 8 divided by 2 will be equal to 5. And even 7 plus 8 divided by 2 will be equal to 7. And we will keep our condition such that R minus L is greater than equal to 1. So whenever it becomes equal to R becomes equal to L or R becomes less than L, we break. Okay. This is how the code will be. L equal to 0, R equal to N. Calculate M, which is equal to R plus L divided by 2. If A of M less than target, L is equal to M. So ideally, if your pointers are here and here, these denote the numbers, these set denote the number with less than equal to target. This set always denote the number greater than equal to target. Not even equal to, just less than target or greater than target, right? So let's try to code our idea of binary search. Oops, it gives wrong answer. Yes, it passed. Exactly, Emma, exactly. You are right. Does anyone have any doubt in the implementation part of this algorithm? They can tell me in the chat if you guys have any doubt. Okay, Mayank, I hope it's clear to you. Does anyone have any doubt? Clear to Rudra? Okay. Okay. Clear to Pratiksha as well. Nice. Okay, nice. Very nice, guys. It's really good to see that you guys are following. Great, Gitansh. Great, great, Dhanusha. Nice, Ayush. Nice, Srishti. Very nice, Neha. It's very important that you guys understand this algorithm of binary search. We'll be doing some problems. I will introduce you to one more aspect of binary search, which has become very, very important, which is known as binary search or answer. So we'll talk about it. Okay, Sneha. Okay, nice. I hope it is clear to everyone. Very nice, Gaurav. So let's try and solve. Try and solve, or maybe let's try and see this last problem of today, which will be on your screen in this moment. Uh, okay, so I'm just deciding which problem to pick. Okay, let's try this one. A very famous problem. Let's help Coco, who loves to eat bananas. There are n piles of bananas. The ith pile has piles I banana. The guards have gone and will come back in h hours. Coco can decide her banana per hour eating speed of k. Each hour she chooses one pile of banana and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. Coco likes to eat slowly but still wants to finish eating all the bananas before the guards return. Return the minimum integer k so that she can eat all the bananas within h hours. Nice, Yuvraj, very nice. Try to read this problem, try to understand it. This is a classical problem when we are diving deep into the concept of binary search on answer. Try to understand this problem. Yes, Gitansh, I will provide notes. Don't worry about that. So, Coco eating bananas, and a very big hint I would like to drop would be binary search on answer. Try to do something along this line. What do I mean by binary search on answer? This means try to find best possible eating speed. Try to do binary search on that. See, there will be something like this. Infinity. These are, what are they? They are eating speeds. Okay. Now think about it. She will be able to eat if she has if she has infinite eating speed, right? She will be able to eat all the bananas. She will be able to eat if she have infinity minus one. Maybe she will be able to eat till six. If you ever find an array, an element where it is not possible to eat, do you think it will be possible less than that value? If there is a value that you found that it is possible to eat, it is not possible to eat. Do you think a value less than that it will be possible? For example, here is a pile. Okay, here is a pile. It's a very simple example. Pile of 7, pile of 5, pile of 4. Okay, you have an eating speed of 7 bananas. Okay, so let's say you take 7. Okay, you eat 7 bananas in 1 hour. Then you pick this pile and then you finish this in 1 hour. You finish this in the third hour. So the answer becomes 3. Let's say the limit of h was 3 only. Now see, if I take k is equal to 6, I will be able to eat this pile in 1 hour and this pile in 1 hour and then this pile in second hour. I will eat this pile till 1. I will finish 6 bananas in 1 hour and then I will take another hour for that left 1 banana, right? So I will take 4 hours, right? So it is not possible to have a speed of 6. Now check if it is possible to have a speed of 5. Same problem occurs. You can eat this in 1 hour, this in the second hour. You eat the 5 bananas of from this pile in 1 hour and the remaining two in the next 1 hour. So you also need 4 hours. So if you find the index which is not possible, you know all the index behind this index will not be possible. And if it is possible at 6, then it will be possible at 7, at 8, at 9, at 10. So you need to find this binary search you have to do, right? I hope it is clear to all. So this is the biggest hint for this problem. We will discuss this problem tomorrow. Tomorrow we will be solving this problem and we'll also be starting with sliding windows, a very important topic when it comes to your placements. Try to code it down, try to think of an approach. I have given you a very decent idea of how you can proceed in this problem. Try to build on that idea, try to think of different observations, try to write those observations, right? Try to come up with different ideas, try to write those observations and try to code it down. Code your approach, or even let's say don't even code your approach, just try to write your approach. And in tomorrow's class, try to discuss with me, write on chat whatever you thought by your own. Okay, don't try to search. See, you will find all the answers if you search on the internet, but try to do it yourself. You will realize where you are going wrong, and tomorrow we discuss with your doubts. So I am expecting at least 4, 5 or 10 students will come with their own implementation of binary search on answer. I want to see how many of you can implement it on your own. And please, by saying that I want to see how many of you implement on your own, I'm saying on your own, not by chat GPT or by seeing online the answers online, right? Try to think of your own. See, that's how you build the capability of your mind. Try to be alone just with a paper, no phone, no laptop, nothing. Try to be with a piece of paper by yourself. Try to think of the algorithm, right? That's the perfect way to grow your mind. So try to think about this problem, Coco eating bananas. Um, I will I will share the link of this problem. Okay, so the today's session is over here. We will meet tomorrow. If we will discuss more problems, and towards the end of the boot camp, I will tell you the patterns we have already solved, and I will give you more problems that you can solve. For example, when we do binary search completely, for now we have done only binary search. Tomorrow we will talk about binary search on answer. There are a lot of problems which use binary search and answer. So there are a list of like more than 15 to 20 problems you can practice and hone that concept. Then we will also talk about towards the end of tomorrow's lecture, we will talk about sliding window. There are more than 30 problems. There are more hard problems related to binary search on answer as well as sliding window. These two topics will be really important. Till now, we have seen hashing. You must remember we did max number of sub arrays with sum equal to k. We used hashing there. We even used hashing in the first problem. We did two sum problem. Remember. So we have seen hashing. We have seen prefix sum. Now it's time to step up our game. We will be talking about binary search and answer in tomorrow's class, and also starting off with sliding windows, ending the boot camp with some really hard problems of array. But trust me, they will not seem that hard because we have done it. We will have done all the patterns in very smooth and very soothing manner. So the only goal I am giving you, the only thing I want from you in tomorrow's session is try to think of this problem, Coco eating bananas. Try to think it by your own. So I hope you guys like today's class. We will meet tomorrow at the same time, 7 p.m. Till then, don't forget to think about that problem, Coco eating bananas. I've already given you a hint. Try to think on that hint. Okay. Till then, bye bye, guys. You guys must find attendance link uh, in the chat as well, right? Or maybe uh, just backtrack this video and you will see. Okay, bye. We'll meet tomorrow. Okay, bye Gaurav. Bye Sanika. Bye.